No, it would not meet exception no. 1 of NEC 250.140. NEC 250.141 allows the use of a conductor in a multi-wire branch circuit as both a neutral and an equipment grounding conductor only if the following conditions are met. Firstly, the conductor is terminated at a device enclosure with an equipment ground terminal. Secondly, the device enclosure is connected to the grounding electrode system. Thirdly, the device itself does not have any accessible non-current carrying metal parts that are connected to its neutral conductor. In this case, the equipment ground conductor is already terminated at the equipment ground terminal of the range. However, the new range requires a neutral conductor, which is not present in the existing branch circuit. The purpose in the equipment ground conductor as a neutral conductor would violate NEC 250.141 because it would not meet the first condition. The equipment ground conductor is not terminated at a device enclosure with an equipment ground terminal. It is terminated at the range frame, which is not an equipment enclosure. Bonding the range frame and neutral terminal does not address the issue of the missing equipment ground conductor. The equipment ground conductor is still not terminated at a device enclosure with an equipment ground terminal. Therefore, it is not permissible to terminate the equipment ground conductor on the neutral bus in the panel and re-identify it as a neutral. A new branch circuit with a separate neutral and equipment ground conductor must be installed to supply the new appliance. Let's delve deeper into the requirements of NEC 250.140 and its implications for appliance circuits, particularly focusing on range installations. Understanding these code provisions is crucial for ensuring electrical safety and compliance. NEC 250.140, specifically exception no. 1, addresses a specific scenario where a single conductor can serve as both a neutral and an equipment grounding conductor in a multi-wire branch circuit. However, this exception is subject to stringent conditions. The first condition is that the conductor must be terminated at a device enclosure equipped with an equipment ground terminal. This means the point where the conductor connects must be a designated enclosure designed to provide a grounding path. Secondly, that enclosure must be connected to the grounding electrode system, establishing a direct link to the earth for fault current dissipation. Finally, the appliance itself should not have any exposed metal parts that are connected to its neutral conductor. This is to prevent the possibility of objectionable current flow on the grounding path. In the described scenario, an existing range circuit is being operated to accommodate a new appliance that requires a neutral conductor, which the existing circuit lacks. The existing circuit utilizes a Type SC cable containing two number 6 conductors and a number 10 bare equipment grounding conductor. The proposed solution involves terminating the equipment grounding conductor at the neutral bus in the panel and re-identifying it as a neutral. However, this approach is not compliant with NEC 250.141. The primary reason for this non-compliance lies in the first condition of the exception. The equipment grounding conductor, in its current configuration, is terminated at the range frame, which is not considered a device enclosure with an equipment ground terminal as defined by the code. The code distinguishes between the equipment grounding conductor and the neutral conductor for specific reasons. The equipment grounding conductor provides a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protection devices like circuit breakers or fuses, clearing the faults and minimizing the risk of electrical shock. The neutral conductor, on the other hand, carries the unbalanced current from the load back to the source. Combining these functions onto a single conductor in situations outside the permitted exception can compromise safety. The suggestion of bonding the range frame to the neutral terminal does not rectify the fundamental issue of the missing equipment grounding conductor. Bonding aims to create an equipotential plane, minimizing voltage differences between conductive parts, but it does not replace the dedicated grounding path required by the code. The original intent of 250.140 seems to address scenarios where there isn't an existing equipment ground. However, in this particular situation, there is an existing equipment ground, but it doesn't meet the requirements for also being the neutral. Attempting to repurpose it as a neutral creates a code violation. Modifying the conductor at the panel by re-terminating it on the neutral bus does not change the fact that it isn't terminated at the device enclosure, where the range is with an equipment ground terminal. Therefore, it doesn't meet the first condition. The correct approach to address this situation is to install a new branch circuit with a dedicated neutral conductor and a separate equipment grounding conductor. This ensures compliance with the NEC and provides a safe and reliable electrical connection for the new appliance. When installing the new branch circuit, it is crucial to adhere to all applicable code requirements, including conductor sizing, overcurrent protection, and proper grounding and bonding techniques. The size of the conductors must be adequate to carry the load current of the new range, as determined by NEC 220. The overcurrent protection device, such as a circuit breaker, must be sized appropriately to protect the conductors from overload. The equipment grounding conductor must be properly sized and connected to the grounding electrode system, providing a low impedance path for fault current. In addition to the NEC requirements, local codes and regulations may also apply. It is essential to consult with a qualified electrician to ensure that the installation meets all applicable requirements. Installing a new branch circuit with a separate neutral and equipment ground conductor might seem like a more involved solution, but it is the only way to guarantee compliance with the NEC and provide a safe and reliable electrical connection for the new range. It eliminates the potential hazards associated with repurposing the existing equipment grounding conductor and ensures that the grounding and neutral functions are properly separated as intended by the code. Furthermore, it is important to remember that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the NEC and local codes. Working with electricity without proper training and knowledge can lead to serious injury or even death. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns about electrical installations. Let's consider a few additional aspects related to this scenario. Firstly, the type SE cable mentioned in the question is service entrance cable. While it's permissible to use SE cable for branch circuits in some cases, it's essential to ensure that it's rated and installed appropriately for the specific application. The NEC specifies the allowable uses of different cable types, and it's crucial to select the correct cable for the intended purpose. Secondly, the size of the equipment grounding conductor is also critical. In this case, the equipment grounding conductor is a number 10 bare conductor. The NEC specifies the minimum size of equipment grounding conductors based on the size of the overcurrent protection device protecting the circuit. It's essential to ensure that the equipment grounding conductor is adequately sized to safely carry fault current back to the source. Finally, proper bonding of metal parts is essential for electrical safety. Bonding involves connecting all non-current carrying metal parts of an electrical system together to create an equipotential plane. This minimizes voltage differences between metal parts and reduces the risk of electrical shock. The NEC provides detailed requirements for bonding, and it's crucial to follow these requirements carefully. In summary, the proposed solution of re-terminating the equipment grounding conductor as a neutral is not compliant with NEC 250.141. The correct approach is to install a new branch circuit with a dedicated neutral conductor and a separate equipment grounding conductor, ensuring compliance with the NEC and providing a safe and reliable electrical connection for the new appliance. Always consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with all applicable codes and regulations. Now, let's elaborate on some potential scenarios and considerations that might arise when dealing with similar situations. Imagine that instead of a range, we were dealing with a different appliance, say an electric dryer. The same principles would apply. If the existing circuit lacks a neutral conductor and the new dryer requires one, repurposing the equipment ground is not an acceptable solution under NEC 250.141 unless all the stipulated conditions are met. The code mandates a separate neutral and equipment ground for safety reasons. The equipment ground provides a low impedance path for fault current, allowing overcurrent protection devices to trip quickly and clear the fault. The neutral conductor carries the unbalanced load current back to the source. Combining these functions onto a single conductor can compromise safety and create the potential for objectionable current flow. Another scenario might involve a situation where the existing circuit is wired with conduit instead of cable. In this case, the metal conduit itself can serve as the equipment grounding conductor, provided that it's properly installed and all connections are tight. However, even in this scenario, the neutral conductor must still be separate from the equipment ground. You cannot simply re-identify the conduit as a neutral conductor. Furthermore, it's important to note that the NEC is updated regularly, typically every 3 years. It's crucial to stay up to date with the latest code requirements to ensure that electrical installations comply with the most current standards. Code changes can impact various aspects of electrical work, including grounding and bonding requirements. It is also important to consider the specific requirements of the appliance manufacturer. Appliance manufacturers often provide detailed installation instructions that specify the wiring requirements for their products. These instructions should be followed carefully to ensure proper and safe operation of the appliance. In some cases, the manufacturer's instructions may even exceed the minimum requirements of the NEC. In such cases, it's always best to follow the more stringent requirements. Let's also discuss the concept of objectionable current. Objectionable current refers to current that flows on the equipment grounding conductor. In a properly wired electrical system, the equipment grounding conductor should only carry current during a fault condition. However, if there are improper connections or other issues, current can flow continuously on the equipment grounding conductor, creating a potential safety hazard. The NEC addresses the issue of objectionable current in NEC 250.6. This section provides guidance on how to identify and eliminate objectionable current. If you suspect that there is objectionable current flowing on the equipment grounding conductor, it's essential to investigate the cause and take corrective action. This might involve checking for loose connections, improper wiring, or other issues that could be contributing to the problem. Now, let's consider a practical example. Suppose you are replacing an old electric range with a new one that requires a 4-wire connection, 2 hots, a neutral, and a ground. The existing range circuit is wired with a 3-wire connection, 2 hots, and a combined neutral/ground. As we've already established, you cannot simply re-identify the existing combined neutral/ground conductor as a neutral. Instead, you must install a new 4-wire branch circuit. This involves running a new cable from the panel to the range outlet containing 2 hot conductors, a neutral conductor, and an equipment grounding conductor. The conductors must be sized appropriately for the load current of the range, and the circuit must be protected by a properly sized circuit breaker. At the panel, the neutral conductor must be connected to the neutral bus, and the equipment grounding conductor must be connected to the grounding bus. At the range outlet, the conductors must be connected to the corresponding terminals in the outlet. It's crucial to follow the manufacturer's instructions carefully when making these connections. Once the new circuit is installed, the old circuit must be disconnected and properly terminated. The old conductors should be capped off and labeled to indicate that they are no longer in use. In conclusion, the NEC places a strong emphasis on proper grounding and bonding techniques to ensure electrical safety. The requirements of NEC 250.140 and other related sections must be followed carefully to prevent electrical shock hazards and ensure the proper operation of electrical equipment. When in doubt, always consult with a qualified electrician who can provide expert guidance and ensure that electrical work is performed safely and in accordance with all applicable codes and regulations. Remember that electricity is a powerful force, and it's essential to treat it with respect. By following the NEC and adhering to sound electrical practices, you can help to create a safe and reliable electrical system.